So today we're going to be looking specifically at water and examining the different phase changes of water on this graph right here. So let's start at point A. Point A, we can see it's currently below 32 degrees Celsius, which is the melting / freezing point of water. So from this information, we can figure out that point A is currently in a solid state of matter. As we all know, the solid state of water is ice. And this actually makes a lot of sense because ice is a lot colder than water, so it makes sense that's below the freezing / melting point of water. So now let's see as we go from point A to point B. As we go from point A to point B, you can see that the temperature is actually increasing here, which means that there's a change in the thermal energy because of the temperature increasing. As we increase the temperature, we're increasing the thermal energy. There's a change in the thermal energy from point A to point B. So as we're heating up the ice is becoming a lot more hotter and hotter, the thermal energy is increasing, and then we reach 32 degrees Celsius. And 32 degrees Celsius, as we might know, is the melting / freezing point of water. So what this basically means is that when we reach 32 degrees Celsius, we melt ice into water, which is a liquid. And the reason why it's both the melting and freezing point is because if you look at it from left to right, it's ice melting it into water. But if you look at it from right to left, it's going to be water that's going to be freezing into ice. And what's important to note here is that from points B to C, there's currently just a flat plateau, which means there's no change in the temperature, which means there's no change in the thermal energy from points B to C. And instead, what's happening is that there's a change in the phase energy. There's a change in the phase energy because ice is fundamentally and structurally different from water. Ice is a lot more rigid than water, so it has to go and change its phase energy. It's going to break up its particles, break up its molecules to become a lot more looser to become water. And water is going to become, in turn, a lot more rigid. By changing its phase energy, it's going to become more rigid and turn into ice. And now, once you successfully converted your ice into water, you just have water right here, and then at point C, and then you heat up your water, and as you heat up your water, the temperature increases from points C to D. So what this means is that the thermal energy also changes as you go from point C to D, because as you heat up your water, the temperature is increasing, which means the thermal energy is changing. Now, once you heat up your water up to 100 degrees Celsius, you reach another threshold point, and this one is called the boiling / condensation point. Now, it's important to note, just a quick side note, boiling could also be interpreted as the evaporation point of water. So you can interpret it as boiling or evaporation point, whichever one floats your boat. So as you go from point C to D, you reach a boiling condensation point to turn water into a gas, and the gas form of water is water vapor. So as you turn water to water vapor, you're going to have to boil it, and as a result, you're going to have to change the phase energy since you're changing a liquid into a gas. And the same thing for liquids and solids. Liquids and gases are fundamentally different. Gases are a lot more faster and a lot more spaced out, so water is going to have to change its phase energy to meet that standard in order to be converted into a gas.
This verse is for those with a dream and a passion. You gotta chase it down, man, don't ever let it pass you. Be your own boss, don't do everything that they ask you. A lot of people gonna pull you down.